Welcome to video lesson 10.7 on operations in scientific notation. Okay. Now, basically our learning objective here, I didn't write it out for this one, but is to just perform operations with numbers that are written in scientific notation. And then we'll start with some notes. So in order to add or subtract numbers that are written in scientific notation that have the same power of 10, we'll just add or subtract the factors, and then we'll make sure our answer is written in scientific notation. Okay. Now, if the numbers have different powers of 10, then we're going to have to rewrite those numbers so they have the same power of 10 first. And then we'll go back, to this first note and add or subtract the factors, okay, and rename into scientific notation if we need to. Remember, for numbers to be in scientific notation, the factor has to be 1 or greater, but less than 10. Okay. Then I just have a couple tips for how to rename numbers in scientific notation. So basically, here you're trying to get the same powers of 10. So you can kind of use these two notes backwards. If you need to add an exponent to one of the powers of 10, okay, you're going to move that many decimal places to the left. So if you needed to add 2 to the exponent, let's say you're going from 10 to the third and you want them both to be 10 to the fifth, because the other number is times 10 to the fifth, then you'll move the one that's times 10 to the third, the decimal 2 places to the left. Now if you need to subtract from the exponent, okay, so if you're going from 10 to the fifth to 10 to the third, then you're going to move the one that's 10 to the fifth 2 places to the right. Move the decimal 2 places to the right. Okay. Those are tips for renaming numbers in scientific notation. So when you move the decimal to the left, you're really adding to the exponent when it's in scientific notation. And if you're moving the decimal to the right, you're subtracting from the exponent because you're losing place values that you have to move the decimal to when you have a smaller exponent. Okay. Now let's do some actual examples. Okay. So for part A, we're adding, okay, so we're finding the sum of these two scientific numbers in scientific notation. So first thing we're going to do is check the bases, okay? The powers of 10 are 10 to the third and 10 to the third. Perfect. They're the same, so all we have to do now is add the factors, okay? So we have the factors here, and then we're going to keep the same base. It's very similar to whenever we add or subtract fractions, we need a common denominator. And sometimes if we don't have a common denominator, we need to rename one or both numbers to get a common denominator. And that's what we're doing when we're adding or subtracting in scientific notation. We need the same powers of 10, and if we don't have that, then we're going to rename one of the numbers into scientific notation with the same power as the other, okay? And then we keep the power that was the same, all right? Now we need to add 4.6 plus 8.72, okay, which equals 13.32, okay? Now, when we rewrite this, 13.32 times 10 to the third, we need our answers to be in scientific notation. But if we recall, scientific notation needs our factor to be between 1 or equal to 1, but less than 10. Now, 13.32 is not less than 10, so we can use the node that we just had here, where if we move, in order to rewrite this into scientific notation, we know it has to turn into 1.332, okay? Now, to figure out what our new exponent will be, we had to move this 1 place to the left, so we have to add 1 to our exponent. So 3 plus 1 is 4. Okay. There are a couple ways that we could do this. Using that trick is probably the easiest. Okay. We could also have just rewritten off to the side 13.32 equals 1.332 times 10 to the 1. Okay. Because if we have 1.332 and we want to get to 13.332 or 13.32, we have to move it 1 place to the right. So that's where that comes from. And then by the product of powers property, we still have the times 10 to the third hanging over here. We would add those exponents. Okay, so that's an additional way that we could solve that one. Okay, so that will work as well. Okay, now part A was done. Part B, we're subtracting numbers in scientific notation. We need the powers of 10 to be the same. Okay, we could either choose to change the 3.5 times 10 to the negative 2 and make that exponent a negative 3. Okay, or we can choose to change the 6.6 and make that exponent a negative 2. Okay, I'm going to choose to go with the higher exponent. Okay, so I'm going to keep the 3.5 times 10 to the negative 2. Okay, minus then, now I need to rename 6.6 so that it's times 10 to the negative 2. Now negative 3 plus 1 will equal negative 2. Okay, so if I need to add 1 to 6.6, 1 decimal place, okay, I'm going to have to move the decimal back, excuse me, 1 to the left, okay, because I had to add 1. Remember, our rule says if you move the decimal left, we're going to add to the exponent, okay, or I could know that 6.6, okay, and I want the exponent to be times 10 to the 1, so I'd have to move it back 1 place, and then I would have 0.6 times 10 to the 1, okay, plus, or times 10 to the negative 2, or negative 3, and that would equal 10 to the negative 2, okay? So I have 0.66 times 10 to the negative 2. Now I have the same powers of 10, so I have to subtract the factors. 3.5 minus 0.66, okay, is going to equal 2.84. Okay, and I keep the same power of 10 times 10 to the negative 2, and that is greater than 1, less than 10, so it is in scientific notation already. All right. Now, when we're multiplying or dividing numbers that are written in scientific notation, we have to multiply or divide the factors and powers of 10 separately. Okay, so now when we multiply or divide, we no longer need to worry about the powers of 10 being the same. It's okay if they're not the same because we're going to multiply or divide them separately. So we look at our factors. Okay, so we have 3 times 5, and then times, now our powers of 10, negative 5, or 10 to the negative 5 and 10 to the negative 2. Okay, 3 times 5 is 15 times 10 to the negative 5 times 10 to the negative 2. Product of powers property again says we're going to add these exponents. Negative 5 plus negative 2 is negative 7. Okay, now I have 15 times 10 to the negative 7. Is 15 times 10 to the negative 7 written in scientific notation? No, since 15 is greater than 10. So I need to rewrite this as 1.5. Okay, so I had to move the decimal 1 to the left, which means I'm going to add 1 to the exponent. Okay, so moved decimal 1 left, so I need to add 1 to the exponent. All right, and negative 7 plus 1 equals negative 6. So that's how I'm going to get 1.5 times 10 to the negative 6. Another way you could do this, again, rewrite 15 and in scientific notation as 1.5 times 10 to the 1, and then use the product of powers property to add 1 plus negative 7, and that's why that works. Okay, I'm just sort of telling you the shortcut. Okay, but you need to understand the mathematics behind it. Now our final example is to find the quotient of 1.5 times 10 to the negative 8 and 6 times 10 to the 7th. Okay, so now we're going to divide the factors, okay, and divide the powers of 10. Now 1.5 divided by 6 is really 0.25. Okay, And now, by the quotient of powers property, I have to subtract these exponents. So that's going to be 10 to the negative 8 minus 7. Okay, and negative 8 minus 7 is the same as adding a negative 7. Negative 8 plus negative 7 is negative 15. Now again, I need my first factor to be 1 or greater, but still less than 10. So I really need to change this to 2.5. And since I had to move my decimal 1 to the right, I need to subtract 1 from my exponent. Now negative 15 minus 1, since I moved 1 to the right, I had to subtract, okay, that's going to be times 10 to the negative 16. Right, and now that's written in scientific notation. You have 4 practice problems here that you could use to try to solve. Okay, do your best. Please make sure you ask questions whenever you have them. Okay, thank you. Have a great day.